I'm Eugene Demaitre, Editorial Director of Robotics 24/7, and welcome to our webcast on new robots emerging for pallet moving and loading. I'd like to thank our sponsors, Locus Robotics and Rapid Robotics. Before we get into our discussion, let's quickly deal with some housekeeping items. If you have any questions for the panelists, please submit them in the Q&A box at any time, and we'll try to get to them. Any that we don't get to, we'll get to respond to you after the presentation. If the slides are not advancing, press the F5 key on your keyboard to refresh your browser. You can also download a PDF of today's slides and check out any downloads related to today's topic in the resources list on the window on the side. If you're experiencing any technical problems, please visit our webcast help guide by clicking the help ? Icon at the bottom of the console. After the COVID-19 boom in e-commerce, many robotic suppliers have shifted and are focusing on the need to efficiently handle boxes, cases, totes, and pallets. How are these systems becoming more specialized? And how are vendors working with end users and integrators to get the most out of these technologies? I'd like to welcome our speakers for today's Robotics 24/7 Roundtable. Jason Walker is Vice President of Market Development at Locus Robotics and co-founder of Waypoint Robotics. And Ruddick Lawrence is co-founder and Chief Technology Officer of Rapid Robotics. Welcome, gentlemen.
Thank you.
Good to be here.
Good to be here.
Why don't we start off with brief introductions? Jason, why don't you start?
All right. I am Jason Walker. I was co-founder and CEO of Waypoint Robotics, which was acquired by Locus Robotics a couple of years ago. And Locus is a company that that offers robots as a service. We do provide an entire solution, and that solution just helps warehouse operators and others really optimize their operations and optimize their labor workforce to do the things that people do best. It's a company that was founded by 3PL operators, for 3PL operators, and they really started with the need and developed the product from there. We do offer 3 different form factors covering many use cases with autonomous mobile robots, and they're all brought together by our Locus One integrated solution. And the interoperability of all of those different form factors of robots and the ability to capture the business intelligence and present it on dashboards and in reports, and that is all part of what you get with robots as a service. RaaS is not a financing model. It's a way to build an organization, and it's a way to deliver a solution for customers that you really got to start from the beginning to do that. And so, Locus is a company that was doing AI before it was cool, and we continue to do even more as we go along. And it's great to be here and talk about the additional use cases that we can address with mobile robots, and that can also be addressed by other types of automation that we can interact with. And I think that's it. I think Ruddick is up next.
All right. Thanks. I'm Ruddick Lawrence. I'm the CTO and co-founder of Rapid Robotics. And what Rapid does is we really think of ourselves more as a robotic workforce company as opposed to a robot company. And the reason for that is we've seen that a lot of the barriers to automation tend to happen because, robot doesn't just get put on your floor and then work perfectly forever. right? It does need to be maintained and upkept as your processes change, as things are constantly evolving. And so our workforce essentially is fast to deploy, and we continue to maintain it throughout the life of the robot. So we become think of it as sort of almost like a temp agency, but for robotics. And the workforce that we deploy are palletizing robots, and we deploy them and, as I said, maintain them, and primarily manufacturing end of line, but also in logistics as well. So here are some statistics. Just we are running essentially a very large workforce that continues to do a lot of the work that all of you are doing. And it's full service. So besides for being able to set it up very quickly, we have monitoring technology that allows us to diagnose and solve any problems, make changes, things like that very quickly, often remotely, but if there's an issue, we come on site. And we have very flexible pricing. So we offer both more upfront as well as the traditional RaaS similar to Locus. So we think this is a really good way for companies to get into automation, or also automate areas of their business that sometimes get neglected. We talk to a lot of companies where the CapEx budget is all taken up by some mainline manufacturing projects, but there's still a lot of value to be had in the palletizing and end of line. And that's where we can come in and really be fast to getting that ROI. So very excited to be here and talk with all of you about where are the opportunities for automation, because even though this is a very highly automated space, there's still a lot of opportunity that we see when we go and talk to customers. And back to you, Eugene.
Thanks, Ruddick, and thanks, Jason. Ruddick, why don't we start with you? You mentioned that you're offering your systems, but what are some of the challenges that are driving your customers to consider automation right now?
Yeah, that's a great question. I mean, I think it's something that's going to be very familiar with a lot of folks in the audience, and the number one is labor issues. And labor issues are obviously getting the right people in and having them, getting enough people for your lines to be fully operating. But it's also reliability. When we talk to customers, we always talk about ROI and talk to them about what is their fully burdened hourly rate. But often not included in that is the cost of recruiting, the cost of downtime when you expect 10 operators to show up and only 7 do, and all of those hidden costs and reliability that robots can really help solve, because these things, once they're going, right, they do the same thing day in, day out. So that's really a major one. But the other one is really, there's often some speed. The robots can be faster than humans. And also, we even see them for safety, but also specifically if they're loading large pallets that are too high for humans to safely do. There's ways of making that possible, but the cost of installing that equipment, if it's not already there, often rivals what you would pay for a robot. So those are kind of the big drivers that we see for adopting our solution.
And Jason, are you seeing that labor is a major pain point as well?
Yeah, it really is. There's not just a growing labor gap, but there's an accelerating labor gap. And it just gets more and more difficult every year to be able to to deliver on the SLAs and KPIs that folks have. So it's, interestingly, we really don't talk with customers who say, I want to get rid of my people. What they say is, I can't get enough people, and I really need to utilize the people I have, in the best way I possibly can. And so having the right robot for the right task, and being able to have people do the jobs that they do best, is really the critical thing that people are trying to do when they're automating.
And both of you mentioned something interesting. We've seen an increasing range of capabilities among robots, from semi-autonomous lift trucks to, you mentioned, high lift and there's very narrow aisle. Let me start with Jason. Are you seeing a trend towards specialized robots? Are the robots that, say, Locus is offering beginning to serve different functions?
Yeah, I think for a long time, we've really the state of the art in robotics relative to the tasks that can be accomplished economically, like where the affordability curve meets the value curve meets the cost to actually do something reliably and safely. We are still at a point where single-use robots, robots that are specially designed to perform a particular narrow set of tasks, is that equation works for those types of robots, and that's why having a palletizing robot, having a pallet moving robot, having a truck unloading robot makes sense. And it's also why interoperability among those things is important. But the cost of a general purpose robot, and really the state of the art of where those types of robots are, it's just not feasible. And so finding a robot that can perform the task you need done, and finding a partner who can supply the broadest range of solutions is really it's the most reliable way to deploy robotics. I think folks that are promising anything broader than that are being very optimistic at this point in time.
Ron, did you want to add to that?
Yeah, and I think it's interesting because we work with robotic arms, which in some ways are a general purpose robot, but they don't do anything until you make them do something. So just because they're general purpose, it's not useful until you have somebody, put in all of the other pieces that make it actually work well. And what we're seeing is exactly what Jason said, where specific purpose robots make sense, but the flexibility that those systems can adapt to is starting to become looser and looser. So it's not that we're seeing a lot of adoption of, oh, this robot can just do anything, move it from one area of your facility to a completely different area of your facility. But instead, it used to be you put that robot in and it would work with that one line, with that one product, doing that one thing. And if you ever wanted to change that, you may as well just do a completely new deploy. And we're seeing the flexibility come into that, where you can have robots that can adapt to changes in what's coming down the line. Some of them can even be moved. And as long as they're still within that same kind of range of what they're working on. So that's where we're seeing it's less top down that can do anything, and more they're starting to expand what each specific purpose robot can do.
And Ronnie, to follow up on that, you mentioned that the robots aren't fairly capable. What technologies have advanced to enable that? Because as you said, these arms are not working in a vacuum. They work with vision and programming and all that. But can you talk a little bit about how the enabling technologies are improving?
Absolutely. And I'd say the biggest sort of enabling technology we're seeing is in the computer vision domain. And that's where not only is what these cameras can do, cameras are getting cheaper. I mean, everybody has one of them in their pocket on their smartphone now. Although ones that we use are usually much more expensive, but it does trickle up, right? It all ends up getting less expensive. Processing power is much more capable, and a lot of the advances that you might read about in AI and machine learning are doing wonders when you apply those to computer vision. Because at the end of the day, what ends up bringing this flexibility is adapting to things that might be very hard to model beforehand, right? If you're in the traditional, if those on the call are used to the traditional way of doing computer vision, you'd sit there and you'd tune it just for what that was going to see. And if the lighting changed, you put up a thing around it so the lighting wouldn't change, right? That was kind of the way that it had to be done. With these new, very flexible abilities, you can have something there, the lighting changes, the box is slightly misshapen, somebody bumped into it. And these models just adapt because they've been trained on so much data and they're able to really work very dynamically there. So that's really allowing for a lot of this kind of explosion in flexibility, is the computer vision, the getting less expensive, combined with the techniques of machine learning and AI.
And with that flexibility, is that something that your customers are asking for or are looking for, or are they asking for something else and this is helping them?
It's a little bit of both. So a lot of times when we talk to our customers, we always say, you're the expert in what you're producing and we're the expert in robotics. And some of that comes with having to explain what can robotics do, what can't they do, what are some trade-offs you might need to make in your facility to make this robot really work for you. And so we don't usually hear our customers come to us and say, all right, I want a machine vision that can look at multiple different boxes. They kind of describe their operations, and what those operations require is this flexibility. And that's kind of where I think that it's really important for webinars such as these, and but just also informing, is really understanding the trade-offs, because there are still trade-offs, right? If you want the fastest robot, then it's going to have to be a bigger robot, and it's going to have to take up more floor space. And all of these pieces kind of come together. But what the machine learning and AI is allowing us to do is to not have to make quite as many of those trade-offs when it comes to flexibility.
And Jason, in terms of the flexibility, let's take Locus as an example. What would you say are some of the differentiators of Locus's robots in addressing some of those pain points?
Yeah, the flexibility thing and the advances in making things more cost effective as well as more effective, it really contributes not just to the breadth of applications and use cases that can be addressed, but also the reliability with which you can address them. The ability for us to go in and Locus started with doing each picking, and then over time they added batch picking, and they added put away, and they added some of our customers will they get a box, they put it on the robot, like get it off the truck, put it on the robot, it drives out, and they put the items away, and then they put the dunnage back on the robot, and it drives to the compactor, and then it picks up something on the way back. Like so that kind of flexibility, the ability to scale the entire fleet up during peak demand times is a huge differentiator with robots as a service, but with the Locus solution in particular. And one of the things that Locus One enables is that sort of elasticity in capacity. And then of course, we have the three different form factors. We have Origin, which is the smaller each picking robot. We have Vector, which is an omnidirectional heavy duty robot that has much higher payload capacity, the ability to hitch onto carts and pull them around. And then we have our largest robot, Max, which can move pallets, and we can do case picking to pallets, and putting pallets away and retrieving them, things like that. So that flexibility and the ability to address all of that with our Locus One platform, and have one point of integration and one point of observing, monitoring the fleet, getting feedback from what's going on, and very importantly, the business intelligence that you get by having the autonomous mobile robots working in the building. That's a huge differentiator, and it's one of those things like, you can buy software packages that'll present the data you already have and nice pictures and charts. But when you add robotics to a facility, the robots are the thing that make the data. They are what allow you to measure different kinds of performance, and what your building is doing and what your workforce is doing. And so, and it can give you feedback on what you need to do to adapt your plans, your workforce, based on what's happening in real time. And so, all that and more. Like there's a lot of things that that automation can offer that goes beyond just the task you might be looking at.
Yeah, and run it. In terms of rapid robotics offerings, you mentioned that you're on the robot arm side. What's the sweet spot that you're serving?
Yeah, the biggest thing that we've found is where our solution really helps with is for folks who need to very quickly automate, and maybe they'll even have in-house automation teams, but can't automate everything they need to. So this is often in manufacturing end of line, as I mentioned at the beginning, because those kind of get neglected when the 5-year automation plans get brought out. And a lot of times the sort of larger systems are much too expensive for the payback that these companies get. So we come in with a very inexpensive offering that can really meet their need perfectly, right? If you want a ton of robot, it's just going to be too much for a line that produces smaller objects. Whereas we bring this in, we can deploy quickly, and then just have the customer almost on day zero start getting that payback for having put in automation, as opposed to sometimes, we're seeing systems integrators have wait times out to 12 months or more. And all of that time that you're not automating is time where you're losing money.
Well, and it gets to the idea of getting help bringing in robotics. And both of you have mentioned robotics as a service, or RaaS. And we know that one of the challenges of this year is that capital has been a little bit harder to get and for everyone. And so, Jason, can you describe a little bit more about the RaaS model and from Locus's point of view, what does it mean?
Yeah, so robots as a service, as I mentioned earlier, a lot of people think it's a fancy word for leasing, but it really is a service. And anybody who tries to present a financing model as robots as a service is, they're not doing robots as a service. And really what robots as a service means to us is that our job is to make sure that material gets moved, the whole company, and whatever it takes to fulfill our part of that obligation is what is included in robots as a service. And so, we go in and we install a network so that the robots have reliable communication. And there's never any doubt about who's responsible for, connectivity. And we have 24/7 support. We have teams of people who are going all over the globe doing installs and deploying new sites. And so all of those people working together are what it takes to do robots as a service. And if you're a customer of that kind of service, what it means is you have a monthly fee that you got one problem to deal with, which is write that check, and then everything else is handled for you. We really try to give white glove treatment to every single customer and make it easy for them. We think that's what robots as a service should be. And some of the benefits that may or may not be obvious to folks depending on how long they've been looking into it. The capital expenditure on the front end is a lot less. And something that's critical is that if, at some point, any subscription will kind of cross over with the cost of capital. And the real question is, what do you have at that point? Like when we all used to buy software as opposed to software as a service, you would think, if I do it when software as a service first became a thing, you'd think, well, I could buy it for this much, and then after 3 years, I'll own it. I might as well pay for it. And the thing that we all kind of figured out is that, oh, well, great. 3 years later, I own this software, but it's useless now. And so while installing robots, they don't automatically become useless after a period of years, but the pace of development in robotics is so fast that you really want part of the service is you get all the upgrades, you get all the updates, you get a system that's monitored and it's constantly improving, and the solution that you get 2, 3, 4, 5 years from now is much better than the one you signed up for. And so that, those are just some of the benefits of doing robots as a service.
And Ruddick, in terms of what Rapid Robotics does, whether it's as a service or an outright purchase, how much training is required for the in-house staff? It's one thing to have the support that your companies offer, but then there still has to be somebody on the floor dealing with the robots. How much do you get involved with that?
Yeah, so our systems are very simple to come up to speed on. For the operators or line leads, there's a very simple interface that allows them to start, stop, see any quick changes if the robot's out of a product or something like that. It's very easy for them to interact with. And we really tailor maintenance of it to the maintenance staff that the facility already has. So this might be basic preventive maintenance, like changing out wear components or checking certain pieces, but it's nothing about the robotics. And that's part of how we can make it so simple, is that our ongoing support that we give, we are the robotics experts and can actually monitor the system and make sure it's doing what it needs to. And if something goes wrong, you don't need your own controls engineer to go over there, figure it out. Maybe it's a different system than the other system across the facility, so they're not as familiar with it. All of that really goes away with what we're offering. In addition, we can actually diagnose problems often faster than systems integrator deployed systems, because we have so many more of those metrics through our system, through our platform that we're monitoring, that we can really dial in very quickly on something that has changed. And again, these facilities are living, breathing facilities. I think that it's very unlikely, unless you're the most dialed in facility, that things don't change, sometimes day to day, but at least over the course of a year. And we are able to help fix the robots when they start drifting away from what they need to do.
And Ronnie, what's the cadence for updates? And again, we're talking about you're providing the services directly. How often does that happen? And is it transparent to the user, or is it something that you take off their hands?
Absolutely, it's both. We definitely take it off their hands and then make it transparent for them. We work in a lot of high uptime facilities, and you don't want to go push updates to them if they're not expecting it. So we'll work very closely with our customers to determine when the right time to do an upgrade is. And this kind of goes back to some of the advantages of RaaS. Is again, RaaS is not a leasing facility. It really is, do you get continued value? And as more and more of the value in robotics is pushed into the software, it allows for this constant upgrade, right? As the vision algorithms get better, as the motion pathing gets better, as pieces of even the HMI get more improved, right? Most of our customers want those advantages because it means that they get the same thing that everyone else does, and their system actually gets better over time as opposed to degrading.
And Jason, you mentioned interoperability before. I know you've been involved in interoperability standards efforts, but can you talk for a moment where the state of that is right now in terms of robots talking to one another, talking to other automation or other systems in the warehouse, and then ultimately talking to the software, there's a WMS, there's WES. What is the state of interoperability, and where does it need to be?
Yeah, so there's a lot of layers to that onion. And one level of interoperability is, when you're choosing a partner, how much can they deliver? And certainly the Locus One platform with the 3 different form factors and all the use cases we can address, interoperability between all of those products is actually something that's kind of new to the world to have that much breadth from a single provider. In addition to that, there are other robotic solutions out there, and RaaS Robotics did a great job of bringing together folks, particularly from the AMR community, to develop an interoperability standard that is open source and really easy to integrate into any system, whether it's an AMR or not. And that provides a framework that any company can use to make products and software and services that are interoperable with other systems. And so the state of where it is, that is a big milestone to have that released. And as companies end up operating in the same building, that framework is there for them to adopt. And I think any folks who are doing that are probably doing it in stealth at this point. So there's that. But in addition to that interoperability, kind of the next layer on the onion is, even if you're not integrated with a WMS, or you're not coordinating, between different automation systems, being able to have an AMR go to a palletizing station like a rapid robotic station and have that pallet automatically be transferred to the robot and have it automatically take it out to where it's supposed to go and drop it off. And potentially having, another robot in front of it that's feeding material into the palletizer. This is where most of the companies that I'm aware of are very conscientious about the points of interface between their solution and the rest of the solution, or the other solutions that are available and surrounded. And so by putting them all together, you can have a comprehensive solution that is interoperable.
And Ruddick, when we're talking about systems communicating with one another, how do you determine what data to collect, to analyze, and then ultimately to share? How much of it helps Rapid with its own systems? How much of it is stuff that the customer needs? How much of it is, obviously there's stuff that has to remain private. How do you make that determination? Do you do that with the customer, or is that something that you have sort of a preset formula for?
Yeah, we generally have a preset formula for that. We find that most customers have pretty similar needs, which is, they might be a little bit sensitive about any personal data, so we tend to stay away from that. But in terms of performance data, the first level is things that help us internally diagnose and improve on our system. The reason for that is, at the end of the day, what the customer is looking for is performance. They want the robot to run effectively, quickly, and without any downtime, 24/7 in some cases. And we've always found that's the primary concern. The data, kind of to I think Jason mentioned it earlier, the data that they can have actionable is almost the cherry on top. It's, well, there was a person here before, and they kind of maybe self-reported how many rejects there were or how many times they were waiting for a part or something like that, if even that. And it was very hard without a separate system in place to gather this data. However, because we now have a robot that is generating that data, we can take a subset of that telemetry data we have and that performance data and provide it to our customers so that they can start to gain insights. And we see this all the time where, we'll come in and we'll want to make sure that our system performs to their specs, and their specs will be a little bit maybe optimistic, or there won't be some data available. And then once it starts running, they'll suddenly have this data in front of them and say, oh, we didn't realize that the machine was starved, that no packages were coming to it for that frequently. Let's go fix that upstream so we can start running more smoothly. And so that's really where we see the big benefit for customers on top of just the automation that they get.
And sort of the next step is delivering those actionable insights, right? Jason, with Locus One, can you give me an example of like some insights that you can then pass on to your customers or the end users that Locus One is able to do?
Yeah. So one really simple example is when all of the orders get pushed out of the warehouse management system and into the Locus system, the robots take that data, they drive out and they park in front of the place where things need to be picked. And the dashboards in the warehouse show you where all of those picks are. And then they also share you where the next picks are going to be. And so you can preemptively send the people out to those places to meet the robots there. That's one small thing. Retroactively, you can get heat maps that will inform ways that you might be able to reslot your warehouse to make it operate more efficiently. So it's having the data be timely, be actionable, and easy to get to. Like that is the key thing to make it useful. Not just for generating reports, but being able to make decisions about how to use all of the other resources at your disposal in the most efficient way possible.
In addition to palletizing, I think, Jason, you mentioned it earlier, there's the notion of being able to load and unload trucks. And at recent trade shows, we've all seen some recent and rather varied attempts to address that problem, including some humanoid robots, which are obviously a lot in the news this year. What is your experience with palletizing and mobile platforms suggest in terms of solutions to that challenge?
It's expensive to have a general purpose mobile manipulator, and truck unloading in particular is extremely difficult. And so being able to do that requires such expensive equipment that, as I said before, it's really hard to find the sweet spot where all the constraints overlap and you have a solution. I think that the idea that you have the same robot will be able to unload a truck and also automatically do its own case picking and its own put away, things like that. I think even for a mobile manipulator, which is much more narrowly defined for what it's supposed to do than, say, a humanoid is advertised as being, even just trying to have a mobile manipulator do all of those things is extremely challenging. And a lot of that has to do with the grasping. It has to do with the perception, has to do with the lighting. Like there's so many little things that when you're offering a solution that is the lifeblood of your customer's operation, it has to work all the time. And the difference between 90% and 100% is gigantic when it comes to new and evolving technology. So sorry, I don't know if that answered your question exactly, but it's just
it gets to the challenge, right? And running, obviously you guys are dealing with the picking and handling side of the palletizing and related applications. What's your take on the different approaches that are being taken?
Yeah, and I agree that it's often very hard to get that general robot that can really do everything. It's both technically challenging to just have it work at all, but the other thing that we see is that it doesn't meet the performance that the customers are expecting. By becoming generalized, often it can't be, you can't optimize it and make it work the fastest without dropping anything, all of those pieces that you really can when it's specialized. And so it'll work in, lower volume facilities where it's so high mix that, you can't specialize, you can't afford the ROI of specializing one robot for one place. But as soon as you get anywhere where throughput matters, where, if the thing isn't there on time, it has downstream effects, if upstream starts backing up, it becomes really problematic. And I think a great way to think about this is currently, so I'm in San Francisco, and we see all of these companies testing out their self-driving cars. And you see them in the news now a lot because they work great when everything's normal. But as soon as you have a construction site, an ambulance, a diversion, they halt and there's a problem there. And if you can show me a manufacturer or a warehouse where a robot running around doing all these different things isn't going to encounter something like that, that's the most well-run warehouse in the world.
Well, and as much as we are looking at automation, there are still need for humans to do the troubleshooting. I know that those of you who are watching, remember you can submit questions. Any questions we don't get to right now, we will pass on to the speakers and they will be able to answer them directly after this webcast. And also remember to check out the downloads and resources. We have a number of questions from the audience. We'll get to as many as we can. Sort of following on to the concept of humanoid robots and mobile manipulation, I guess we'll start with you, Ruddick. How soon can we expect to see robot arms on mobile platforms doing picking and palletizing?
Yeah, so we've seen already actually some mobile arms on, robot arms on mobile platforms. And what ends up happening, they've been slow to adopt. And I think, again, it's some of this problem of if you have your arm on the mobile platform and it's actually moving around picking, sort of like you might imagine a human might do, you have to make some trade-offs. And it doesn't end up making as much sense as having the mobile solution, similar to a Locus product, and the ARM solution, similar to a Rapid product. And this goes back to that specialization. So what we're starting to see in terms of mobile robots is not so much mobile, but kind of like the original laptops, where these things were so big and heavy that you're not just moving around to a cafe and using them, but it does allow you to work from one place and then go somewhere else and work from that place. So we're starting to see some interesting dynamics there, where the ability to set up and tear down these systems is fast enough that you can move them on a monthly basis, let's call it. But in terms of really adoption of mobile manipulators, we're not seeing as much of that.
Jason, do you want to add to that?
So the company that Waypoint spun out of was a hardcore R&D company that made fully autonomous mobile manipulators for research labs. And they were very cool, very specialized, very expensive systems. And so, our team has some pretty good depth in that area. And there are many challenges with doing mobile manipulation. But one of the biggest, toughest challenges of mobile manipulation is the energy and the power. And when you're talking about palletizing, you're almost by definition, you're talking about putting cases of things onto a pallet, and those are almost automatically heavy. And that means you need a big arm, not necessarily a cobot most of the time. And the big arms want to run on 3-phase power. They want to be bolted to the floor. They want to have a cage around them. And so when we were doing mobile manipulation projects, we always really drilled our customers on, why does this have to be a robot? We would make them defend the choice, and just because it's cool doesn't make it a good business decision. And if, it's not good for them, it won't be good for us. So the fact is, if you wanted to palletize on an autonomous robot, then having the mobile robots bring the stuff to a station where you can supply the power and bolt it to the floor and put up appropriate safety stuff is often going to make a lot more sense. Or you build the pallet, as you pick it, that kind of thing. So it's will it come soon? I don't know. Probably not, right? Every 2 to 3 years, the next amazing battery technology was here to save the day for like the last 30 years. And it just, it's a slow grind. So like, that's just one facet that makes it a tough problem. And honestly, that really, it circles back to the sort of general purpose thing, right? It's we're getting there, but it isn't going to happen overnight.
And on a related question, Ruddick, someone asks, when do you think robots will be fast, efficient, and adaptable enough to varying conditions that they will be competitive with humans? And that gets to the idea of, robots replacing humans. Can you elaborate on that point?
Yeah, absolutely. My argument, I know the spirit of the question, but as I would say, they already are competitive with humans, just in very specific areas. Now, obviously, this is asking more about, where can they be fully adaptable? But one of the things to understand, I think, about how the advances in cognition and AI and machine learning work that is very confusing for when we're looking at how people work is when a person is really good at one thing. So they're good at putting this peg into this hole, and you move them to some slightly different task. Oh, it's a click that has to click in. They'll probably be okay at it. That is not at all the way that AI works. AI can be great at one task, and there's an adjacent task, and it falls absolutely flat on its face. Now, as it gets more and more sophisticated, the number of these adjacent tasks that it can work on becomes many more, things that it can do. But at the end of the day, it just doesn't have that flexibility of humans. I mean, humans are just, think about how you can take someone and put them in training for a week, and now they're very good at that thing, and put them in training for something else for a week, and they're very good at that. So that's going to be, I think, a really big limitation for a long time. But that doesn't mean that there isn't areas where today you can start deploying robots where they'll start to act with sort of human-like intuition. I mean, that's kind of what we're doing is a lot of the pallets that we see need a little bit of human intuition. The boxes come in slightly different positions. Some of them might have some issues with them. There might be the wrong box every once in a while. And those are the kinds of things where you can start to expect human-like behavior. But in the general case, I think it's going to be quite a long time just because of how adaptable people are.
You mentioned the adaptability, and obviously in some cases there's a human supervision or a human to robot handoff. What's a reasonable expectation of throughput in terms of picks per hour? Right now we're still talking palletizing, but and how much of a need for redundancy is there?
Yeah, that's a really good question, because it really gets to the heart of, will this palletizing solution work for my specific use case? And every use case in manufacturing is a little bit different. So it's a little bit of it depends. A lot of this is on how big are the cases, how heavy are they? Can the robot pick more than one case at once? So for smaller cases, right, you can just wait for 2 of them to come up and then do one big pick where it picks them all up and puts them on the pallet. What is the pallet pattern that it needs to match to, and can that be adjusted? Sometimes we see that can be sort of designed for automation. It can be adapted to what the robot can do. But in general, we look at kind of our target for our system is around 1,200 cases per hour. That's with multiple case picking. So for larger cases, it's going to be obviously much slower. But and then another thing we designed into our system is a manual workaround. And the reason for that is not that the technology is not reliable, but when the system goes down, that is often, it's about when, like where you are in your production, where the system goes down. And so in some seasons, if the system, something changes and it goes down, it can be very quickly brought up, and that's perfectly fine. In others, even that 5 minutes of downtime might be a real problem. So we always build that in, because redundancy is always just a really good sort of plan.
And Jason, in terms of the going from concept to implementation and dealing with mixed case pallets and those kinds of challenges, what are some common oversights that when Locus is working with customers that you guys have to address?
Sorry, can you re-ask the question? What
Sure.
What kind of?
Yeah, when you're working with customers and you're trying to set up something like a palletizing application, right? What are some common issues that you run into that you find that you have to help them with, or that you have to troubleshoot?
Yeah, I think just thematically, one of the most common things is the mental framework different folks have for making assumptions. And we see the world the way an AMR sees the world, and we make certain assumptions about what's obvious in terms of where things need to be located and how wide aisles need to be and things like that. And folks who are running a different kind of business make totally different assumptions. So if you have a large, powerful autonomous mobile robot or any other large piece of equipment that's powerful and it has a safety system on it, part of the safety system is the empty space around the thing, right? And so I find a lot of customers think, I have a 6-foot aisle and, that thing's less than 6 feet wide, so it should be fine. And yeah, we can make it go down that narrow aisle, but, it's going to have to go slowly. We're going to have to restrict traffic from other people and devices. And so really trying to anticipate those assumptions, and the more you do it, the more of them you capture and the more you try to get in front of. But I think assuming is probably the big risky thing, right? You really have to say, this is what I think it is, this is what I think it isn't, and I want you to say it back to me. Tell me what you think it is and what you think it isn't. And that's the best chance you've got of trying to settle on what really needs to happen.
Someone else in the audience asked a similar question. When moving pallets, how do you determine when to use a robot like Max versus an autonomous forklift? Is there a threshold of size or of how things move? How do you determine that typically?
Well, I think it's there's lots of things. There's typically if you have a vehicle with forks on it, you need a pretty long runway to be able to line up to it. And so we often have customers who want to be able to drop off a pallet at the end cap of an aisle, and it's tight quarters, and having the omnidirectional capability of Max allows the robot to get in there and align up to a pickup and drop off station and offload the pallet. And then, a V&A truck, a very narrow aisle truck, for example, could pick it up. But there are lots of examples like that where just maneuverability is key. But if you have all things being equal, if the form factor itself, and so mobility and agility are that's kind of one category of several where it's really just about getting the right form factor for the application. But if all of those things were equal, then you look at, what does the company look like? How do they do things? How long does it take to deploy? How many sites do they have deployed? Can they scale up for peak? That, all of those other things that come into the picture. So it's not a very exciting answer. It's just like a lot of times with robotics, again, and this speaks to the sort of the narrow specificity of how robots are built at this point in history. The Max does not have forks. And so if you have an application that really needs forks, nobody at Locus is going to try to talk you out of that, right? In fact, we'll try to talk you into it. So, but there are just some tasks that are obviously better suited for others, for a variety of reasons.
Well, and that's where robotics as a service, as a model, right, is an ongoing consultation. Someone had asked, we have time for just one more question. How does one budget for a pallet moving robot or an unloading robot as RaaS? And I was going to put that question to you, Ruddick, but I already know that the question will be, it depends. But do you have a standard approach for, sort of pricing and dealing with that sort of thing?
Yeah, we usually work with our customers to make sure that there is ROI for them there, and including the intangible ROIs, like safety and people showing up every day and things like that. But because similarly to if you need a forklift, you need a forklift. We want to make sure that our customers are getting value out of our robots. Because of our ongoing RaaS model, we are completely aligned with the customer, right? If we deploy it, we then make sure it's working for them. We want them to keep coming back to us year after year. So we really do a lot of that diligence up front and work with them. And what we usually look at is, the kind of big variables that come into it are, what are wages like in that area? How many shifts are you running? And then what is the inability to find operators costing you, right? What is that really costing you in downtime or needing to flex from other areas? So those are the big drivers that we then, kind of work with the customer to plug in and figure out, make sure it really matches up.
Well, Jason and Ruddick, thank you so much for your insights. It's great to have this, and obviously we can keep going, but want to make sure that our audience has a chance to get their questions answered offline. I'd also like to thank our sponsors, Locus and Rapid Robotics. Please remember to check out the QR codes on the screen, and this will be available to download on demand, so you have a chance to look at them later. Remember to visit Robotics 24/7 for all the latest developments in practical automation. Subscribe to our newsletters and register for our next free webcast on maximizing throughput with goods-to-person automation in November. In the meantime, remember that our free Robotics Applications Conference, a one-day virtual event, is coming soon on Wednesday, October 18th. I know Elsie and Jason, and I look forward to seeing all of you then. Thank you again for your time.
Thank you.
Thank you.